This is Shakil Ahmed. In this tutorial, we will discuss about k-mean clustering. K-mean clustering is basically an unsupervised machine learning algorithm used for partitioning a data set into a number of clusters. Usually, we say the number of clusters as k. The goal is to group data into homogeneous clusters from a given data set. And when we prefer k-mean clustering, so when we have a clear idea of how many clusters we are going to make and how clusters are roughly a, an ideal average size, uh, there should be enough number of observation within a cluster and want to easily interpret the clusters and centroids. So what are the steps? It start with choosing the number of clusters k. This is very important, and we have different methods like elbow method and Silhouette analysis and other domain-based knowledge to decide the number of clusters and then initialize the centroid. We randomly select k data points from the data set to initialize as the initial center points and then assign data points to clusters uh, based on distance matrix. We assign a value or an observation to the nearest centroid or the nearest cluster where the distance is minimum, and update the centroids based on a recursive uh, iterative process, and then we get a final appropriate number of clusters with appropriate cluster size. So if you want to know about Silhouette score and David Bolden index, data are used to decide the number of clusters. You can just visit on these sites. If you need, I can share in the comments as well. Then I will use a dataset from UCI machine learning repository. This is basically a data set on heart disease. We try to classify patients based on different risk factors, and then we can see how many individual in a group has certain characteristics or not. So we start by installing this package, that is UCI ML repository. You need to import data from UCI machine learning repository directly, and then from this we import fetch UC repository, then fetch UC repository, and then ID of the dataset, that is 45. So this is for heart disease. We can just run this, and then we specify X and Y. X consists of features and Y consists of targets. But for constructing clusters, we don't need data on Y, we need data on X only. And then we can print heart disease metadata, that is the additional details about the data. And then we can print the variables, X variable. These are the X variables we have in our data set: age, sex, CP, and uh, blood pressure, cholesterol level, and other clinical and demographic characteristics. So now we have data and we want to make clusters based on the given data. So we first impute the missing values using the simple imputer command. We need to import simple imputer from scikit-learn impute, and we also need numpy to filter the numbers and transform the data. So we are now using number imputer, that is simple imputer strategy is mean. If you want to replace the mean, you can write mean, and if you want to replace with mode or something median, something else, then you can change accordingly. And then you will get the x number imputer and fit transform. So we are imputing axis and then transforming. Uh, Basically, we are getting the data after imputing the missing values. You can print some a few observations in X as well. Okay, print X. It's not working. So this is an array. We need a data set, so we can't just print the head observations. Although you can print X all in all. Now we have X as the imputed values. Then we first import pandas as PD, and then we from scikit-learn we use preprocess to convert the value of X on a standardized scale with mean 0 and variance 1, and then we from scikit-learn decomposition we import PCA, and then matplot library we import PLT, and then we standardize X to standard scale, and then we fit a k-mean approach k-means, and then we decide number of clusters, and then random start, and that is used for randomly choosing the k-means. And if you want to change the number of clusters, you can change. I am trying first with three clusters, and then clusters k-mean fit predict X scale. You need to just import your X data, that is an array X scale, and you can see the size of the how many variables we have. We have 13 variables and 303 observations. So you can just check. Now we have already fitted the cluster, and we can check the principal components. PCA for visualization, PCA number of components is equal to 2. We only take basically we need to see the k-mean clusterings, so we need to visualize the values on XY scale. So we just convert it, we just obtain the principal components of axis, two principal components, and we see how we can visualize the clusters based on the two principal components. So using the PCA command, we obtained first two components, and then PCA fit, we fit a principal component to obtain the coordinates using the X data, and then we get two coordinates, coordinate 0 and coordinate 1, and C is equal to clusters. These are the clusters centers, and then these are the color map colors, and alpha is 0.6. Basically alpha is just the aspect ratio of the map. And then PLT scattered, PCA transform, k-mean cluster centers, and then we just display the centers on the map, the centers of the uh, clusters we obtain using the k-mean clustering. So we just obtain the k-mean cluster centers. So we are plotting cluster centers, and then S is equal to 200, and color is red. This is size and this is color, and you can just plot with title xlab ylab. You will see a scatter plot for principal component 1 and principal component 2, and these three colors are showing three different clusters, and the red colors with cross are showing the cluster centers. So this is just a visualization of clusters we obtained here for the heart disease data. So we just categorize the data into three parts, and we are visualizing the through two principal components of the data. Out of 13 variables, we extracted two principal components, and we are just visualizing based on those two principal components. And you can also see the labels of the clusters we have. For example, first observation is in cluster 0. For example, this is cluster 0, this is cluster 1, and this is cluster 3. So the first three observations are in cluster 0, and the fourth observation is cluster 1, and fifth observation is in cluster 5. So you can just visualize them, and you can even you can value the labels as well. From scikit-learn matrix, we import Silhouette score and Davis Baldwin score to check the performance of the for different values of k. We just see the performance of the clusters, how the clusters are displaying well. So Silhouette average, Silhouette score, and X, and then clusters. Similarly, David Baldwin average. This is the command, and the inputs are scaled and clusters, and we can print both the values. 0.12 is Silhouette score, and David Baldwin index is 2.4. So we can just see for three clusters we have these two values. Now we will check for we can check for the same for example uh, two clusters. This is for three clusters, and we can see what value we get. Now we get two clusters, and these are the labels. And now we can check the Silhouette score is a little increased, and this David Burden index is a little bit decreased. So this is much a little bit improved than the previous one. So we can now we use the elbow method. We basically we are what we are doing from SK clusters. We import k-means and then matplot library pyplot. We import it as PLT, and we are obtaining the sum of square error. That is basically the uh, within cluster sum of square, that is called sum of square of error. So we plot the sum of square of error. You can see k-means, and we obtain the number of clusters. We just get a k-means from using the k-mean clustering approach, and we again fit using x scale. Basically, we are changing k in k range, and k is starting from 1 to 10. So we for different values of k, we are getting the k-mean clustering, and for all we are getting the sum of square that is appended using the k-means inertia. Means for all k we are getting sum of square, and then we are just plotting k range on x-axis and sum of square on y-axis, and then title, PLT, y labels and x labels, and the title. So we can just show this, and you can say the sum of square is smallest for cluster at cluster 9. So you can decide the number of clusters as 9 for a better reduced sum of square. So what is k-mean clustering? K-mean clustering we have already decided. We just made the homogeneous clusters based on the distance between the data points to their nearest center, and we get a good uh, picture of data using the uh, uh, different clusters, and we can categorize. Basically, this is just an unsupervised learning, and we categorize the data based on the uh, given features. For example, and we can change the number of clusters, and we need to decide based on the uh, sum of square, basically. The smallest sum for the clusters, number of clusters is 9. We get the smallest within sum of square. But on the other hand, there is a problem that we will left with a smaller number of data, and the extreme is we can consider that one data point has one cluster, so that is the other extreme. And we can make one cluster, and we can make an n clusters. So both of these are not a good idea, but ideally the elbow method basically decides when it start drops, then you need to decide the number of clusters here. So the ideal number of cluster is 2, and we also noticed that the Silhouette score was better for 2 rather than 3. So then you just need to check for the elbow method for deciding the number of clusters. I think it is enough to have a quick idea about the clustering. Thank you so much.